Hello everyone. This is R. Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. Today we are going to discuss about the another problem from CPU scheduling. So this is the problem statement. Consider the following set of process assumed to have arrived at time zero. Consider the CPU scheduling algorithms, shortest job first and round robin. For RR round robin, assume that processes are scheduled in the order P1, P2, P3, P4. If the time quantum for round robin is 4 millisecond, then the absolute value of the difference between the average turnaround time in millisecond of shortest job first and round robin. So round of two decimal places is dash. So we have to find the difference between the two algorithms. Okay. And how many processes they are given? Totally four processes like P1, P2, P3 and P4. The P1 process burst time equal to what? 8. The P2 process burst time equal to what? 7. And P3 process burst time equal to what? 2. And P4 process burst time equal to what? 4. How many algorithms they have given? Two algorithms. One is the shortest job first. Another one is what? Round robin. Okay. We will see one by one, shortest job first and round robin. Before move on to these solutions, I want to convey something. Okay, in shortest job first means what? Which job execution time is less? We have to take that shortest job first. Okay, and with respect to all four process, with respect to shortest job first algorithm, which one is the less time? P1, P2, P3, P4. So P1 is 8, P2 equal to 7, P3 equal to 2, and P4 equal to 4. For shortest job first algorithm, first the process P3 will take place first. Then after that, the P4 will take place because the burst time equal to 4. Then the process P2 will take place and the process P1. This is for shortest job first. And round robin, everything comes under order wise. So P1, P2, P3 and P4. If what is the time quantum? For every process, 4. Okay. So total for time, first time for process P1, 8. So two times the P1 will be repeated and total process time for P2 7. So the time quantum equal to 4. So remaining time 3. So 4 plus 3 2. So two times the process P2 will repeat. And out of time quantum 4, but the process P3 is only 2. So only one time the P3 will repeat and P4 also one time because the time quantum is 4 and the burst time also 4. So we have to calculate the SJF and the round robin like that. So we will see one by one. So this is a solution for shortest job first. The out of four process, which one will take place first? Na process P3 because the previous table, the process P3 execution time equal to 2. So this is the least time. So shortest job first means what? P3 will execute first. So starting time equal to 0, the maximum allocation time equal to what? 2. Within the 2 units, the process P3 will be completed. Okay, then the another process will start. Out of remaining three, P1, P2, P4, which one is shortest time? P4 is the shortest time, burst time, 4 only. So at time T2, P4 will start at, so already 4, 4 plus 2, 6. At time 6, the process P4 will be completed. Then the remaining two process, P1 and P2, the P1 burst time equal to 8 and P2 burst time equal to 7. So at time 6, the P2 will start, then 7 plus 6 13. Okay, at time 13, the P2 will be completed. The next P1 only pending. So the burst time equal to 8. So at time 13, the P1 will be started. So P1 13 plus 8 21. So this is what a concept of SJF. Now we according to shortest job first CPU scheduling, we have to calculate the average turnaround time like a P1, P2, P3 and P4. So the P1 total completion time equal to what? 21. So starting time equal to 0. So 21 minus 0. And the P2 P2 completion time equal to 13. The starting time equal to 0. So 13 minus 0. And the P3 completion time equal to 2. So 2 minus 0. And P4 completion time equal to what? 6. So 6 minus 0. So likewise, 21 minus 0 plus 13 minus 0 plus 2 minus 0 plus 6 minus 0 divided by overall process, 4 process. So we will get a 10.5 millisecond. I hope you understand that SJF. Next, we move on to a round robin method. I already told the round robin is what everything comes under in order wise only, and the total time quantum is what 4 milliseconds for every process. So the first process is P1, total burst time equal to I think 8. So first 4 quantum will be allocated for P1. The another next 4 quantum will be allocated for process P2. The process will comes in order wise. The overall burst time for process P2 equal to 7. So the first 4 will be allocated. So you keep in mind plus process P1 8 out of 8 4 completed, and P2 total burst time equal to 7 out of 7 4 completed, remaining 3 will be there, and process P3 the total burst time equal to only 2. So, but the total quantum is 4, but only the 2 will be allocated. So, starting time equal to 8. So, 8 plus 2, 10 only. And the next process is P4. The P4 total burst time equal to 4. The time quantum also 4. So, totally both are matched. So, P4 start at 10, end with 14. And the remaining 2 process pending. So, P1 and P2 again order wise already P1 4 completed. Out of 8, 4 completed. So, remaining 4. So, 14 plus 4, 18. And the next process P2. So, out of 7, 4 already completed. So, remaining 3. 18 plus 3 equal to 21. So, according to round robin CPU scheduling with the time quantum 4 milliseconds, we have to calculate the average turnaround time. So, for P1, the P1 is ended at 18. So, 18 minus 0. And P2, the P2 is end at 21. So, 21 minus 0. And P3 end at 10. So, 10 minus 0. And P4 end at 14. So, 14 minus 0. And overall time divided by number of process, totally 4 process divided by 4, so which is nothing but what, a 15.75 milliseconds. So now we have to calculate the difference between average turnaround time. So shortest job first minus round robin, so 10.5 minus 15.75 millisecond, the total difference is what, 5.25 milliseconds. I hope you understand this concept. Thank you.